Advanced Math class. We are actually jumping to Chapter 13 for a couple lessons. I think they fit in pretty well, and this is all that I want out of Chapter 13. It's the law of sines and law of cosines. You would have seen this in geometry. We're going to hit it again a little bit, and hopefully it goes pretty smoothly for you. Okay? So, law of sines, we'll cover that. Areas of oblique triangles. Oblique is just a non-right triangle. Okay? So if it's not a right triangle, it's called an oblique triangle. Okay? So oblique triangles in a section, triangles that have no right angle, so not a right triangle. Standard notation, remember for a triangle, if this is angle A, it's capitalized, and then side A is opposite and it's lowercase. So the angles are capital letters, and the sides are lowercase. So that's the standard notation for a triangle. So in order to use these laws, you need at least one side and the measure of any two other parts of the triangle. So you have to have a side of the triangle in order to use these laws, and then either of the two that we're going to have. So these are coming from geometry as well. Angle, angle, side, angle. Remember, those are congruency theorems, which means if two triangles have two consecutive angles that are the same and a side that are the same, then they're going to be congruent triangles. They're going to be the same size, same shape. Two sides and the angle opposite of them, SSA, this is not a congruency theorem, but it can be, and we'll talk about this one a little bit more. Okay, side angle, two consecutive sides congruent, and then an angle. These right here, this is what we can use the law of sines to solve. So if it's any of these two situations, we'll use the law of sines. The next lesson will cover the law of cosines. And if you have three sides known, or a side angle side, two sides and the included angle, you will use the law of cosines. Okay, so here is your law of sines. So law of sines says if you have a triangle that fits the characteristics, either angle, angle, side, or angle, side, angle, or side, side, angle, side length A over the sine of A, most of these will be in degrees, so make sure you're in degree mode when you're doing it, equals side length B over the sine of B equals side length C over the sine of C. So you can pick any two of these to figure out what you need to do. It's just a proportion. Okay, these are going to be proportional to each other. Okay, so A over sine A, B over sine B, C over sine C. So first example for the triangle in figure 13.2. Ta-da! 13.2. C is 102. Looks like more specifically 102.3. B, angle B is 29 or 28.7. I'm not sure why those numbers are different there. So we're going to call this 102.3 and 28.7, and B is 28 feet, or better known as 27.4 feet. Why are those different? Okay, find the remaining angle and sides. So for the law of sines, you always need an opposite side and angle. Okay, so if you're looking to do the law of sines, you'll need a side and then the angle that is opposite of it. So you always are looking for that. That's going to be your given. So our given in this case is that I have the 27.4 over the sine of 28.7. Make sure you put the sine with the angle. Equals, now this is the one I'm going to find first because I have 102.3. So it equals C over the sine of 102.3. So see where that comes up. This is our given. Here's our unknown. Side over sine of that angle opposite of it equals side over the sine. Now these can be flipped. You can put the sines on top if you wanted to. Okay, so to solve C, we have to take 27.4, multiply that up, times the sine of 102.3 and divide it by the sine of 28.7. Make sure I am in degrees. 27.4 times the sine of 102.3 divided by the sine of 28.7. That's a 7. So that is a 2. So 55.7. So C is about 55.7. Okay, so that's this one right here, 55.7. Okay, now we can find angle A. The measure of angle A would just be 180 times 102.3 minus 28.7. So 180 minus 102.3 minus 28.7, 49 degrees. Okay, now we're going to do the same thing we did for side C for side A, because we know this is 49 degrees right there. Okay. So I'm going to go back to my given. 27.4 over the sine of 28.7 has to equal A over the sine of 49. Multiply that up. So A is going to equal 27.4 times the sine of 49 divided by the sine of 28.7. And crank that out. 27.4 times the sine of 49 divided by the sine of 28.7. 43.1. So we have found the remaining sides. There's side A, there's side C, and there's angle A. Okay, another sort of word problem with it. We have a pole, looks like a utility pole, and now common site. The common site is that it's leaning 8 degrees from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So that's 43 degrees right in there. How tall is the pole? So we have 22. We have 43. We know this angle here is 8. Okay, so there's 8 degrees. That's the 8-degree angle from the vertical. They want to find this length. So you notice they want to find this length. The opposite angle is 43. So if I'm looking for A, I'm going to have a sine of 43. So I need one other set of given. Now the only other thing I have is this side length. I don't have this side length. So if I have this side length down here, which angle do I have to find? So you go opposite and you have to find this angle up here, which we know this is 43, this is 8, and this is 90. So this is 98 right in there. So 180 minus 43 minus 98. Not times. 39 degrees. So this angle up here is 39 degrees. So that is my given. I'm going to do 22 over the sine of 39 equals A over the sine of 43. Multiply to the top. So 22 times the sine of 43 over the sine of 39. That is going to be A. 22 sine 43 divided by sine of 39. So 23.8. 23.8, what are we in? Feet. So, but 23.8, you never really see that on tape measure. That probably is the answer. But I like to know, okay, how much of an inch is that? So I minus the 23, take that times 12. That's about 23 feet, 10 inches. Alright, keep moving. Now, one more example I'm going to put in here. What if you need an angle? Okay, so what if you know this is 10 feet and this is, I don't know, let's make it 22 feet. And let's say this is 52 degrees and you're looking for that. And this is where the inverse operations come into play. Okay, because you don't know that side. You are going to go 10 over the sine of 52 equals 22 over the sine of x. So cross multiply, so 10 sine of x equals 22 sine of 52. Divide by 10. So sine of x equals 22 sine of 52 divided by 10. Now, when you're looking for an angle, you have to use the inverse operations. So you take the inverse of both sides, you're going to get x equals the inverse sine of this value right here. We'll cover more with inverse operations here coming up. So inverse sine of 22 sine 52, make sure this is all in this parenthesis divided by 10. So like that. So parenthesis 22 sine 52 divided by 10. Don't divide by 10 later. And draw another parenthesis. Ooh, this doesn't look good. 52, not 25. Wait, there's a 25 there. What's that from? I did that right. Okay, domain error. This isn't looking good. 22 sine 52 divided by 10. That is outside the sine range. Oh, this triangle's not possible like this. I need a smaller angle. Okay, that's my issue. That's what I get from making it up on the fly. So let's change this to the 25. Let's change that to a 25. So that's 25, that's 25, that's 25. So let's see if that works. I made a bad triangle. No? Okay, let's just go with 5. I really made a bad triangle, huh? You're 22 sine of 5. That should work. There you go, 11 degrees. 22 sine 25, what's going on here? Divided by 10. 25 would have worked also, 68 degrees. Okay, so what do we do wrong? 22 sine, so I want the inverse sine of 22 times the sine of 25 divided by 10. That time it worked. Okay. Not sure. So 68.4 degrees. Again, they will give you problems that actually work out. That's the degree sign, not $68. All right, I put a dollar sign on there. Okay, 68.4 degrees. So the ambiguous case, SSA, you saw 2 angles and one side determine a unique triangle. However, if 2 sides and one opposite angle are given, then 3 possible situations can occur. So this is like if you have 10, 12, and 14 degrees. So side-side angle, guess what I had just drawn over here? Side-side angle. So that's kind of where I ran into issue there. I should have done a angle-side angle or something like that. The side-side angles, you can either, no such triangle exists. They're going to give you 3 different situations. Okay, so where you'd have to watch out for this on the assignment, okay, there's the definition of law of sines. This one we'll get to in a little bit. Here's the law of sines. See, this is angle, side, angle. Those are okay. This is B is 15, C is 49. So they give you that one and that one. That's angle, angle, side. There's some degrees in minutes. Remember to divert that to a decimal. You take 40 divided by 60 and add that to 7. This one would be 10 plus 15 over 60. Okay, you convert those to decimals. Oops, showing you all the answers. You like that, huh? There we go. So things like this, side, side, angle. That's angle, angle, side. This one's angle, angle, side, so you're okay. This one could be a side, side, angle. So you have 2 different cases that are going to show up on this one. Okay, 2 degrees, 45 minutes, so take 2 plus 45 over 60. Again, side, side, angle. That's where you're going to be looking at this situation here. So what you have to check on is the height. And this table right here is what you want to take a screenshot of. Make sure you have. You can pull it up on the notes from the Google Drive. Okay. H is B times the sine of A. So if you're given A, B, and an angle, 2 sides and an angle. You're given 2 sides and an angle. You're going to take the letter that is different, so I have A and A. You're going to take this one right there, and you're going to take it times the sine of the angle. So you're going to take the side length that is not opposite the angle, not opposite the given angle, because sometimes they may not give you A's and B's, they may give you A and C's or B and C's, times the sine of the angle. So once you do that, if A, now this one, is less than H, you don't have a triangle that's possible. If A equals H, there's only one triangle that's possible. Okay, that's a right triangle. So this is what you have. If A is less than H, that's not going to be long enough to meet up down here on this side right here, because this angle is set. If A is greater than B, there's only one that's possible. So you could check that right away. If A is greater than B, this is the first one you want to check here. You have one triangle possible. If A is between H and B, then there's two triangles possible. Okay. So if A is less than or equal to B, none. If A is greater than B, that kind of fits in there, there's just one. Okay, so A is greater than or equal to B, that's an acute triangle. If A is greater than B, so probably the, interesting. Okay, so that table we're going to come back and reference. So for the triangle in figure 13.4, A is 22, B is 12, A is 42. So side, angle. Find the remaining sides and angles. So first of all, A is greater than B. A is greater than B. So since A is greater than B, we know we do have a triangle. We only have one. So we can just go ahead like we normally do. They want us to find the remaining sides. So here's my given. 22 over the sine of 42 equals 12 over the sine of B. This one should work out better for us. Okay, so it's going to end up, I'm going to multiply the cross, the 22 is going to come over, so the sine of B equals 12 times the sine of 42 divided by 22, and so we need the inverse sine of 12 sine 42 divided by 22. That's what B equals. So see if this works out better this time. So inverse sine of 12 sine 42 divided by 22, 21.4. Okay, so this one right here is 21.4. Now to find C, I would take 180 minus those two. That'll find C. And once you find C, then you can use the law of sines and find side length C. So 180 minus 21.4 minus 42, that is 116.6. So it would be 22 over the sine of 42 has to equal C over the sine of 116.6. So 22 sine 116.6 divided by the sine of 42. So C is about 29.4. Okay. Show that there's no triangle for which A equals 15, B equals 25, and A is 85. So here, A is less than B. Okay, if you look in the book, they're going to go into more detail, but A is less than B, there's no triangle. So, since A is less than B, the triangle does not exist. Okay, according to the ambiguous case SSA. Okay, show that there are two triangles for which A equals 12, B equals 31, and A is 25. Okay. Let me go back to this, because that doesn't satisfy fully. If you do, let's check H. H, remember, is B times the sine of A. So H is 25 times the sine of 85. 25 times sine of 85, h is 24.9. That's really close to 25. Okay, so a is less than b, and a is less than h. So that is that right there. So check. These two things have to be true together. Okay, a is less than h, a is less than or equal to b. This is when you have two. A is less than b, but it's greater than h. Okay, and that's what's going to show up here because a is less than b. 12 is less than 31. H is 31 times the sine of 20.5. So h is about 10.85. So h is less than a, which is less than b, so we have two cases. Okay? So and these are the two cases that happen here. Okay, because here's your fixed angle, 20.5. You have a 31, you also have a 12. So you can get an obtuse triangle like this, or you can get this sort of obtuse triangle down here, because there's 31, there's the 12, there's your angle. So if you imagine this kind of like a fixed point right there, and this swings on a pendulum, this is where your other triangle is right there. See that right there? That's where that one matches up. So that's where you get the two triangles, but h has to be less than what your a is for that to happen. Okay, so since h is less than a is less than b, you have that. Okay, use the law of sines to solve the triangle. Round your answers to 2 decimal places. Okay, a and b. So we have a is greater than b, so we're going to have some answers here. Okay, and since a is greater than b, we don't have to worry about the two situations here. Only when a is less than b. So if this is a, b, c, a is 36, a is 8, b is 5. Okay, normally triangles I think would go a, b, c that way. So you can use that given. Sine of 36, 8 over the sine of 36 has to equal 5 over the sine of b, and then you can solve for b. Okay, so inverse sine of 5 sine 36 divided by 8. So b, 21.5 when you get it, 21.55. And then from there you can get the rest of them. Okay, a lot of practice with this. Trying to hurry here. 110 and 15 degrees, so that is, okay, a is greater than b. Okay, go back and check. A is greater than b, we're going to have one triangle. So 110, 15, that's 110 plus 15 over 60. 10 plus 15 over 60, that's 110.25. Okay, so there's a, put b down here now, c is up there. So 110.25, this is 48, b is opposite, which would be 16. Okay, so you would find this angle right here first. So sine of 110.25 over 48 equals the sine of b over 16. So we need the inverse sine of 16 sine 110.25 over 48. And we get b to be about 18.22. And again, from there, you can get the rest of it. Law of sines, okay, a is less than b. So now we got to check the h. H is b times the sine of a, which is 12.8 times the sine of 58. That is the height of the triangle, by the way. So 12.8 sine of 58, just 10.85. Okay, so that is greater than h. So a is less than h, which is less than b. So no triangle. No triangle. Okay, area. Here's your formulas for area. 1/2 BC sine A. Notice these are the side angle sides. So BC sine A, AB sine C, AC sine B. So notice that all three letters are represented, 2 side lengths and an A. The C sine A is just basically giving you the height of the triangle. Okay, that's 1/2, that's B times the sine of A basically. 1/2 base times height is what that's figuring out there. So you have to have a side angle side, really, is what you have to find this, use this formula. Okay, so if you have B times C and sine of A, so there's side, angle, side like that. B, C, sine A. AC, sine B. AB, sine C. Whether it's an acute or an obtuse triangle, it works. Okay, so find the area of a triangular lot having two side lengths and that angle. So area is 1/2 AB sine C. So 90 times 52 times the sine of 102. Plug and chug. So 0.5 times 90 times 52 times the sine of 102. There we go. 0.5, 1/2, 90, 52, sine of 102. So area is 2288.9 square meters. There's your area. Okay, directional bearings, we're coming up here. A degree measuring 0 and 360 is representing north. 0 degrees represents north, measuring clockwise in direction. So if you ever listen to any air flight shows, we want a heading of 090. That'd be due east. Okay, these should be listed in 3 digits. So a drawing of 240, a bearing of 240, north is 0 degrees. Okay, here's this one. So 240 degrees, that would be somewhere over here. So 240 would be like that. All clockwise, going this direction. So this is kind of different than what our vectors did. Okay, draw a bearing of 045. This would be north. 045 would be just 45 degrees right there. Okay, so those directional bearings, these are just bearings, and they use 3 digits. 359 would be almost due north, to just be a little bit right there. That'd be 359. Okay, those are pretty straightforward. These vector bearings, a vector direction, is a little bit more confusing. It begins with a north or south statement, then it lists an acute angle followed by east or west to determine the direction of rotation. So a vector bearing, this is north, so we're going north, and then we're going to go ahead 35 degrees west. North, 35 degrees west. So on my compass, here's north, and I'm going to go 35 degrees west. So you notice that could be, if I take 360 minus the 35, I get 325. That could be a bearing of 325, going this other way, or north 35 degrees west would be heading in this direction. The vector of south, 20 degrees east, so I'm going south, and now I'm going to go 20 degrees east. So east is this direction, west was this direction. Never eat sour wheat. Never eat soggy watermelon. So 20 degrees east would be right there. So convert a heading of 350 degrees into a vector bearing. Well, 350 would be right there. So we are just 10 degrees away right there, so it'd be north 10 degrees west. Okay, this is west. Okay, so the course for a boat race starts at point A. And figure 13.9 proceeds in the direction of south, 52 degrees west. So there's a 52 degrees south, 52 degrees west. That means this is true south. To point B, then in the direction south, 40 degrees east to point C, and finally back to A. Point C lies 8 kilometers directly south of point A. Approximate the total distance of the race course. So we know this is 8. This is 52. If we can find this angle here, or this angle here. Okay, so if you look, this is south, 40 degrees west, and this is due south as well here. So what we have here is alternate interior angles from geometry. So we know this has to be 40 degrees. So alternate interior angles, because we have 2 north-south lines. So if that's 40 degrees, we can take 180 minus 52 and minus the 40, so that's minus 92, so that'd be 88 degrees there. So now we have all 3 of our angles. We can use the law of sines to figure out the missing sides. Okay, try to get this done real quick. So it'd be 8 over sine 88 equals, this is A, let's see, A over sine of 52. So 8 sine 52 divided by sine of 88. So A is 6.3, and C is going to be over the sine of 48. So I just need to change this to a 48, and C is approximately 5.9. So 5.9 plus 6.3 plus 8, it's about a 20.2 kilometer race. All right. Whew. I think that went longer than I planned, but a lot of examples in there. I want you to show it. You can definitely watch, rewatch, don't watch, whatever works for you. So good luck. Let me know what questions you have. See you again. Stay Bluebird strong. Yeah.